Hello guys, so in this video, we're going to do a few things that we didn't have time to do in class. First of all, I want to do a little bit review of what we have learned in class. And then we will jumpstart to where we left off, which is factoring trinomials whose leading coefficient is not equal to 1, okay? And in this section, there are actually two different methods that we can use to factor a trinomial with leading coefficient not equal to 1. Okay, so the first one is called decomposition of the middle term, and the second is called cross method. We'll see what these terms mean in about 20 minutes. So I will make separate videos for the two methods, and then I'll make a third video. And in that video, I'm going to go through a lot of examples using these methods to make sure that we understand what's going on here. Okay, so let's just get started. So the first part of this video is to review what we have learned in class. So what did we see in class? We learned how to factor a trinomial with leading coefficient equal to 1, right? So let's just quickly go over the steps. Okay, let me give you an example. I'm not going to spend too much time on this topic because if you didn't fully understand this part, you can always go back to our class video to review, okay? I just want to do a very quick review so we can have a smooth transition to trinomials that have leading coefficients not equal to 1. Okay. So x squared plus 3x plus 2, we have a few conditions. M plus n is equal to the coefficient of this middle term. We have done this multiple times in class. So m plus n is equal to 3. N times n is equal to the constant. So mn is equal to 2. So we're looking for two integers that satisfy both conditions. Two integers m plus n that satisfy m plus n is equal to 3 and m times n is equal to 2. And the answer is m is equal to 1, n is equal to 2. Like I said in class, whether you assign the value 1 to m, 2 to n, or vice versa, doesn't really matter in this case, okay? Because we're going to write this trinomial as the product of x plus m times m plus n. So whether m is equal to 1, n is equal to 2, or m is equal to 2, n is equal to 1 does not matter here. Because if we switch two terms in multiplication, the result stays the same. So and x plus 1, x plus 2. So this is our answer. And don't forget to verify your answer, okay? Don't forget, if you get really comfortable with the process, then you don't really need to verify your answer. But at the beginning, like at the early stage, I think you should always verify your answer, okay? So verify. If we got the answer correct, then if we expand this, it should give us the original trinomial. Okay, distributive rule is applying here. X times x, x squared. X times 2, 2x. 1 times x, x. 1 times 2, 2. We combine the like terms. X squared plus 3x plus 2. Okay, compare this and this. They're the same. So the answer we got is correct. So this is what we learned in class, right? Okay.